Ambystoma maculatum, the spotted salamander. They emerge during the heavy rains of late winter and early spring to embark on a massive migration journey to breed. Many of these salamanders can be seen crossing busy roadways that have intersected their migratory routes, as they journey back to the very place that they were born. While there are many roads that have been closed to allow safe passage for these animals, to see that these salamanders cross safely and finish their migratory journey. More conservation efforts are taken in places where roads aren't closed down, to give these salamanders a fighting chance. Upon reaching their destination, male spotted salamanders will enter the vernal pool, and female salamanders aren't too far behind. Swarms of them can also be seen, nudging and pushing one another as they lay spermatophores that will eventually fertilize a female's eggs. And once the eggs are laid, the next generation of spotted salamanders will begin to develop, and the race against time to grow up will begin. The season of spring in early April welcomes a mix of chilly and warm temperatures. Scattered vernal pools are nestled in and out of the surrounding forest, and cradled within these unassuming bodies of water is new life waiting to emerge. The next generation of spotted salamanders lay quietly in their algae-filled egg capsules. Euphila algae swirls within each egg capsule as the embryo develops. The algae provides a beneficial symbiotic relationship to the host embryo. It provides more oxygen as these salamanders grow. In fact, the algae is so intertwined with the spotted salamander that studies have even shown this algae is present even within the cells of the embryo. At this point in mid-April, an overall salamander shape can be seen, with pigmentation developing and eyes as well. However, this clutch of eggs still has a long way to go. The overall growth rate can vary from egg mass to egg mass, depending on temperature and even exposure to light or shade. And while movement can be seen in some of these egg capsules, some other egg masses are much further along. The eggs shown here, found on the same day as the previously shown egg masses, are much further along with prominent features such as gills and tail fins, and are very close to hatching, with one larva even partially outside of the egg capsule already. And it's a good thing too, because the sooner they hatch, the better. Water is already beginning to evaporate at a rapid pace, fragmenting the pools. And some pools are nothing more than a remnant of what they once were, leaving behind any eggs and ceasing their development. At the end of April, newly hatched spotted salamanders have begun their race against time to grow up. Limbless salamander larvae with feathery gills and a paddle-like tail now pepper the debris-filled vernal pool. Sensory barbels can be seen just below the yellow to golden color eyes, and the mottled coloration of their body will change as they grow. These salamander larvae are less than half an inch in length, and will require food that's even smaller than they are. The tiny organisms seen swimming around are all on the menu, and these salamanders currently go by sight to hunt. And if all goes as planned, they will grow and then eventually metamorphose, becoming a terrestrial salamander by the end of summer. The month of May has arrived, and with it, a few passing showers. The much-needed rain has helped to fill the vernal pools once more. However, they still remain fragmented, and the remaining empty egg masses have begun to break down. The spotted salamander larvae have since grown as well. Their front legs have developed, and their overall body coloration has also deepened and changed. The tips of their feathery gills have also developed a noticeable yellow coloration. However, while these larvae are growing at a steady rate, time is still against them, and predators such as dragonfly larvae lurk nearby, hidden amongst the darkened leaves and muck at the bottom of the pool. But these spotted salamander larvae are also still predators, still hunting the tiny organisms swimming all around them. But can they outgrow the rate of evaporating water? A nearby vernal pool has all but completely dried up, along with any spotted salamander larvae that were residing in it. Another vernal pool rests on the opposite side of the forest. This mere puddle has formed from accumulated water, where off-road vehicles are known to drive through. And this pool is much smaller than the first one. It is much more shallow, and with the possible threat of human traffic, growing up in these waters is risky business. And yet, spotted salamander larvae are found residing in this pool as well, playing by the same rules as the others, preying upon smaller organisms while avoiding predation. But there is a notable key difference between this population and the population in the previous vernal pool. These salamanders are bigger and growing faster. Much further north, a third vernal pool resides peacefully under the shade of the trees. This one is larger and deeper, and the cool temperatures in the area make this a desirable amphibian habitat. And beneath the surface, massive amounts of tiny organisms such as Daphnia swim all around, and their salamander larva predators lurk nearby. Spotted salamander larvae have hatched in these waters as well, and even though they've hatched much later when compared to the previous two populations, their home is abundant with food. However, these spotted salamanders are not the only predators residing within this pool. The much bigger marbled salamander larvae also call this vernal pool home, and the size difference between these two species is noteworthy. Many of these larvae are well over an inch in length, making these animals a huge threat to any spotted salamander larvae that happen to swim nearby the mouth of the marbled salamander. While both species are in the genus Ambystoma and closely related, the spotted salamander is on the menu. The summer heat of June has arrived, as sunlight breaks through the trees to shine upon the once filled vernal pool. The spotted salamander larvae are no more. However, the second vernal pool remains filled, as it lingers in defiance against the high temperatures. And while the very first vernal pool has completely dried up, all hope has not been lost. The spotted salamander larvae here have since grown much larger, and are now equipped with not only front legs, but hind legs as well. But even though they have grown quite substantially, they still have a long way to go, as the harsh heat of summer weighs down on this population of spotted salamanders. Back at the northern vernal pool, the heat of summer has also been unkind to this area, as only mere puddles now remain. The much larger marbled salamanders are nearing metamorphosis, and just in time. As the month of June drags on, this vernal pool will completely dry up, and along with anything left in it. And the differences in size and growth between the marbled and spotted salamanders couldn't be more clear. While the marbled salamander prepares to move to its terrestrial environment, the spotted salamander larva behind it is not yet ready to leave its aquatic environment. The marbled salamander has the advantage of being able to overwinter and being born first in these waters, and thus being given a head start to escape the evaporating vernal pool. Even though this population of spotted salamander larvae are also equipped with all 4 limbs, these are still much smaller than the previous vernal pool population. While there are many advantages to living in a vernal pool, the trade-offs can be quite harsh and even deadly. The lack of oxygen and high temperatures, and lack of abundance in food as these animals grow larger, are among the harsh realities. Large predators are also capable of taking advantage of these pools, and the larval amphibians that reside within won't be able to escape. Time is simply not on their side. The heavy summer heat of July weighs heavily on the entire area. The constant heat wave that has come through has shown no mercy to the vernal pools in the area, and yet the spotted salamander larvae of the second vernal pool, the shallow little mud puddle, are still alive and thriving, while the other 2 locations have completely dried up by now. This population has been able to withstand their harsh living conditions, and will soon be on their way to metamorphose and leave their aquatic environment. And upon inspection, only a few days later, one salamander has crossed the finish line in the race to grow up and escape the harsh life of the vernal pool. And while it may take some time to fully adjust to its new terrestrial environment, it is now essentially a miniature version of the adult. This salamander will spend the remainder of its life on land and take up to 3 years to mature and reproduce and start the cycle all over again. But until this salamander is ready to reproduce, next year's larva will also be faced with the harsh realities of living in a vernal pool and run the race against time to grow up.